Good morning, one and all. This is Rajesh Shekhar Reddy, Assistant Professor of Mathematics, Government Postgrad College, Pavagada. In third semester BCA, we have computational numerical techniques. So, in the previous sessions, we discussed about the bisection method and Newton-Raphson method. While using this Newton-Raphson's method, there are so many bad points. That means Newton's method is failure while finding the roots of given equation. What are such points? In this session we discuss. So Newton's method, to find out the root, we take the iterative formula, that is xk plus 1 is equals to xk minus f of xk divided by f dash of xk. So what are the uses of it? Newton's method has quadratic convergence. That means the error is squared at each iteration. That means the number of accurate digits doubles while doing this. But there are so many bad points while doing this Newton's Raphson method. The first one is Newton's method requires calculating the derivative. We require derivative. In many cases, the function is given by a complex formula and an analytic expression. For the derivative may not be easy to calculate. Sometimes the given function is a complex one. We are unable to find its derivative. For this one, what is it? The solution. In such cases, we can use secant method, which approximates the derivative by using the slope of a line through 2 points on the function. Next, other con is if the initial value is too far from the true zero, that means the given value is very far from the real root. In such case, Newton's method may fail to converge. It has only local convergence. In such cases, what is the remedy? Practical implementation of Newton's method should put upper limit on the size of the iterates. So implementation of Newton's method should put an upper limit on the size of iteration. Instead, we can use bisection to obtain a better estimate for the solution. Okay, so whenever the initial value is too far from the real root, in such case we better to apply bisection method to find out the better approximation for real root. For example, for some functions and some starting points, it may enter an infinite cycle preventing convergence. Suppose f of x, if you take x cube minus 2x plus 2 and initial point 0 as the starting point, if you take, the first iteration produces 1 and the second iteration return back to 0. So the sequence will oscillate between the two without converging to a root. There is a problem like that. Other con is if the function is not continuously differentiable in the neighborhood of the root. Suppose the function is not continuously differentiable in the neighborhood of the root. So neighborhood of the root means, so at that root, if you take the interval left side few points, right side few points, that one we consider the neighborhood of the root. It is possible that Newton's method will always diverge or fail. Why? Because the function is not differentiable in the neighborhood of the root. Whenever the function is not differentiable in the neighborhood of the root, Newton's method will always fail. In such case, try another initial point. We have to change the initial point. For example, Newton's method diverges for the cubed root, which is continuous and infinitely differentiable except for x is equals to 0, whether its derivative is undefined. At x is equals to 0, cubed root is not defined. The fourth one is Newton's method will fail in cases whether the derivative is 0. For any given function, the derivative is 0. In such case, Newton's method will fail. When the derivative is close to 0, the tangent line is nearly horizontal and hence may overshoot the desired root. Here also we have to find the solution. We try another initial point. Initial point we have to change to apply this Newton's method whenever the derivative at that point is 0. Next, another con is in some cases the iterates converge but do not converge quadratically. Some cases the iteration converge but do not converge quadratically. In such case, what will be the remedy? Use simple methods like bisection, which in that case converge as quickly as Newton's method. So better to apply bisection method when the iterates convergent but do not convergent quadratically. For example, if the first derivative is 0 at the root, then convergence will not be quadratic. If you take the function is x square, so the iterative formula is xk plus 1 is equals to xk minus f of xk divided by f dash of xk. That means x to the power of k divided by its derivative means 2. So in such case, derivative is 0 at that root, the converge will not quadratic.